Next problem is I equals to 1 by 2 to 2 tan inverse x upon x square minus x plus 1 into dx. To solve this problem, we can see limits is 1 by 2 and 2. So they are reciprocal of each other. To solve this problem, we can assume x equals to 1 by t, so that limit will interchange and tan inverse x become as cot inverse x, because we know tan inverse 1 by x is nothing but cot inverse x. So we can think about this property. So here dx equals to minus 1 by t square dt. So it will become I equals to, if lower limit is 1 by 2, x equals to 1 by 2 and x equals to 2. If x is equals to 1 by 2, then t equals to what will come? 2. If x equals to 2, then t equals to 1 by 2. Then it will become I equals to, if x is 1 by 2, t value is 2, so this will become 2. If x value is 2, then t become 1 by 2, so this value is 1 by 2. Then this will come as tan inverse 1 by t, this is minus 1 by t square dt, divided by 1 by t square minus 1 by t plus 1. Now we can write as I equals to 2 to 1 by 2 tan inverse 1 by t is nothing but cot inverse t minus 1 by t square dt. This will become as 1 minus t plus t square divided by t square. So t square getting cancelled. We know fx into dx, a to b is nothing but b to a minus fx dx. So here we can see I equals to, this become as 1 by 2 to 2 cot inverse t in dt divided by t square minus t plus 1. Now we can change the variables. So t equals to x we can put. So this will become I equals to 1 by 2 to 2 cot inverse x divided by x square minus x plus 1 into dx. Now this equation and first equation we add, so it will become 2i equals to 1 by 2 to 2 tan inverse x plus cot inverse x divided by x square minus x plus 1 into dx. You can see the initial problem. So from here we can say tan inverse x plus cot inverse x is nothing but pi by 2. So we can say 2i equals to 1 by 2 to 2, this is pi by 2, and this we can make as perfect square x minus 1 by 2 whole square plus 3 by 4 into dx. So this we can write 2i equals to pi by 2 we can take outside, 1 by 2 to 2 dx upon x minus 1 by 2 whole square plus this we can write as root 3 by 4 whole square. We can say dx upon x square plus a square integration is nothing but 1 upon a tan inverse x by a. So from here we can say I equals to pi by 4, 1 upon a is root 3 by 2, tan inverse x is nothing but x minus 1 by 2 divided by a is root 3 by 2 into, this is limit is 1 by 2 to 2. Now if we put the limit I equals to pi by 4, this is I think 2 root 3 tan inverse upper limit if I put, so 2 minus 1 by 2, so 2 minus 1 by 2 divided by root 3 by 2 minus tan inverse 1 by 2 minus 1 by 2 divided by root 3 by 2. So this will be I think getting here 1 by 2 0, tan inverse 0 is 0. So pi by 2 root 3 tan inverse, this will come 4 minus 1 divided by 2 divided by root 3 by 2. So this will come equals to pi by 2 root 3 into tan inverse root 3. So this is nothing but pi by 2 root 3 into tan inverse root 3 is pi by 3. So this will come as pi square divided by 6 root 3. Next is integration ia equals to 0 to 1 x power a minus 1 divided by log x into dx. Now to integrate this function we can see this function is not integrable directly. Now To integrate this one, we have to differentiate with respect to a. So if I differentiate with respect to a, then x power a differentiation will come as x power a into log x. Now if I differentiate with respect to a, log x will become what? Constant. Then this dx is also become as a constant. So we can differentiate directly this function inside function, because this limit is nothing but what? X limit. So if we differentiate with respect to a, so x I a dash equals to, this is limit x equals to 0 to x equals to 1, x power a differentiation what? Nothing but x power a into log x, minus 1 differentiation is what? 0, and this denominator log x is outside only because this is a constant. So if you are differentiating with respect to a and variable present inside only, so we can differentiate inside directly. So this is getting, log x is getting cancelled. So ia dash is equals to, if I integrate now x power a, so this will come x power a plus 1 divided by a plus 1, and limit will put what? X equals to 0 to x equals to 1. So ia dash is equals to, if I put x equals to 1, so 1 power a plus 1 divided by a plus 1 minus x equals to 0, if you put, so 0 power anything is 0. So this will come as ia dash is equals to 1 upon a plus 1. So from there, if you integrate ia dash with respect to dA, so this is 1 upon a plus 1 into dA. So this will give ia equals to ln modulus of a plus 1 plus c. Now given equation is ia is equals to x equals to 0 to x equals to 1, x power a minus 1 log x dx. In this equation, if I put a equals to 0, so this will come 0 to 1 x power 0 minus 1 divided by log x into dx. So this value will give 0 to 1, this 1 minus 1 is what? 0 into dx, so this will give 0. So from there, if I put I a equals to 0, so I0 equals to ln 1 plus c. So I0 is what? 0, ln 1 is 0 plus c. So c equals to what becomes 0. So from here you can say ia equals to ln modulus of a plus 1 plus, this is our answer. So from there we can say, if I take I equals to 0 to 1 x power a minus 1 divided by log x into dx. So this answer will come ln modulus of a plus 1. Similarly, if I take one more example, if I take I equals to 0 to 1 x power a bracket 1 minus x divided by log x into dx. So similarly, this problem how to solve? 0 to a, if I multiply, what will come? X power a minus x power a plus 1, correct? Then log x into dx. So what we can do in this one, 0 to a, we can do x power a minus 1 minus, if I take x power a plus 1 minus 1, so we can say this minus 1, this minus minus plus 1, so that is getting cancelled, divided by log x into dx. So if I separate, we can write 0 to a x power a minus 1 divided by log x into dx minus 0 to a x power a plus 1 minus 1 divided by log x into dx. Now from there we can say this value will come as ln modulus of a plus 1 minus this value will come ln modulus of a plus 1 plus 1. So this will come ln modulus of a plus 1 divided by a plus 2. This is your answer of this problem. Next problem is integration 1 to infinite ln x power m divided by x power n dx. M comma n belongs to n and n is not equals to 1. So to solve this problem, what we can do, this type of problems we have to use u into v. So in this one function we will take as integrating function, one function is differentiating function. Which function we have to take integrating function? Those function we can integrate easily. So we can integrate x power n easily. So what we will write, I m comma n. This we will write 0 1 to infinite ln x power m and x power minus n into dx. Now we will integrate this one with respect to x. So here ln x is outside. Integration of x power minus n is x power minus n plus 1 divided by minus n plus 1, and this is will come as 1 to infinite. Now minus 1 to infinite ln x differentiate what m into ln x power m minus 1 into ln x differentiate 1 by x, and this is x power minus n plus 1 divided by minus n plus 1 into dx. Now if I put I m comma n, so if I put infinite, so this will become limit x tending to infinite ln x power m divided by x power n minus 1 into 1 by 1 minus n, minus if I put ln 1 is what, ln 1 power m divided by 1 power n minus 1 equals to 1 minus n, correct, minus here if I see it will come out m upon 1 minus n integration 1 to infinite ln x power m minus 1, and it will come out x power minus n plus 1 and minus 1 into dx will come. So from here we can say if we solve this one limited separately, so if I say limit n tending to infinite ln x power m divided by x power n minus 1, we are solving separately. So we'll use L'Hopital rules we can use because this is what infinity by infinity form. So if I differentiate m into ln x power m minus 1 into 1 by x, and this differential will come what, n minus 1 into x power n minus 2. So if we simplify this one, limit x tending to infinity, if we simplify what will come, limit x tending to infinite m into ln x power m minus 1 divided, this x will come in numerator, denominator what will come, this is n minus 1 into x power n minus 1. So again if you differentiate, this power will be what, decrease, but this will be remain constant. So if you differentiate m times, so this will come as what, this will come as some constant k power some constant b into x power n minus 1 into limit x tending to infinite. That means if you put some constant, some number divided by infinite, so that will come as 0, correct. So we can remove this one. Okay, so from here we can say I m comma n, this one, this will come as what, 0, because this value is coming as what, 0. This is ln1 is coming what, 0, so this will also come as 0. Here if we see m upon n minus 1, so if I say this we can take inside also, so what will come, m upon n minus 1 can we write, this is minus, correct, so we can take this inside, so n minus 1, this is what, 1 to infinite ln x power m minus 1 and x power what will come, minus n into dx, correct. This is nothing but what, I m minus 1 comma n, correct. So we can say I m comma n is equals to m upon n minus 1 I m minus 1 comma n, where I m comma n is nothing but what, 1 to infinite ln x power m divided by x power n, correct. And this integration of I m comma n is coming what, m minus 1 comma n. So if I put I m minus 4 n comma n, so what will come, so this will come out, instead of m you will write what, m minus 1, this side will come as it is n minus 1, this side will come what, this is m minus 1, so this will come out m minus 2 comma n. Similarly this way you have to write, so I m minus 2 comma n if I write, so m minus 2, this is m minus 1, this is m minus 1, so m minus 2, this is also m minus 2, this is n, so this will be also n minus 1, this will come what, m minus, this m minus 2, this m minus 1, m minus 2, m minus 2, this will come out m minus 3 comma n. Similarly if I take I m minus 3 comma n, so this will come out m minus 3 divided by n minus 1 I m minus 4 comma n. So like that, similarly if I do like that, so and if I put this value in this one, this value in this one, this value in this one, so this will come what, I m comma n, so first term is what, m upon m minus, n minus 1, second term will come m minus 1 divided by n minus 1, third term will come out m minus 2 divided by n minus 1. Like that if I do, it will come out 2 by n minus 1 into 1 upon n minus 1, and this will come I 0 comma n. Now if you find I 0 comma n, so this is nothing but 1 to infinite ln x power m. M is what? 0. X power minus n into dx. So this will come out x power minus n plus 1 divided by minus n plus 1. This is 1 to infinite. So 1 upon 1 minus n we can take outside. Inside bracket we can write as x power n minus 1 1 to infinite. So if I put 1 upon 1 minus n, if I put infinite, if I put, so 1 by infinite minus 1 by 1 power n minus 1. So this will come what? 1 upon 1 minus n. This will come 0 minus 1. So this will come what? 1 upon n minus 1. So if I put here this value, so what we'll get? I m comma n. So here we can say m minus 1, m minus 2, 2, 1. So this we can say m factorial. Now here if I take n minus 1, so n minus 1 power is what? So if I can say minus 0, and this term we can write as what? M minus 1. So this we got m cancel, this will come out 1. So 0 to m minus 1, how many terms will be there? Total term is what? M terms. So this power is nothing but m power will be there. So this will come n power n minus 1 power m into I 0 comma n. So 0 comma n value you have to put. So what will come? I m comma n is equals to m factorial divided by n minus 1 power m plus 1. So this value is nothing but what? 1 upon n minus 1. So this is a integration. Problem is I equals to dx upon root over sine x plus alpha into cos x minus beta cube. So this is indefinite integration problem. So to solve these problems we will do what? I equals to dx divided by root over sine x plus alpha into, we can do what? Cos x minus beta we are multiplying. So this will come out cos power 4 x minus beta. Correct? So if I simplify this one further, what will come this one? Dx upon root over sine x plus alpha divided by cos x minus beta into cos square x minus beta into dx. So here what we'll do? We will take sine x plus alpha divided by cos x minus beta is equals to t square. We will differentiate this one. So this will come what? Cos square x minus beta. Denominator is square, then denominator is outside. Cos x minus beta, then numerator differentiation is what? Cos of x plus alpha minus numerator is as it is sine of x plus alpha, then denominator is what? Cos. So that differentiation is what? Minus sine x minus beta into dx. So right hand side is 2t dt. Now this one we can say this is suppose a, this is b, this is a, this is b, this is a. Correct? And this sign will come what? Minus minus, this will come plus. So this is what? Cos x minus beta into cos x plus alpha plus sine x plus alpha into sine x minus beta divided by cos square x minus beta into dx equals to 2t dt. So this is nothing but cos, if it is plus cos, if I say cos a minus b formula, this will come out cos a cos b plus sin a sin b. So if I use this formula, this is nothing but what? Plus sign, so it will come out cos x minus beta minus x minus alpha divided by cos square x minus beta into dx equals to 2t dt. Now from here we can say this is cos of, if I use my x getting cancelled, minus alpha minus beta, so this is minus alpha plus beta divided by cos square x minus beta dx equals to 2t dt. Now if I substitute, if I use this one in this integration, so I equals to 0 to, so dx divided by cos is, this is square only, cos square is nothing but what? 2t dt divided by cos, this will come as what? Alpha plus beta, because we know cos of minus alpha equals to cos of alpha. Correct? Into 1 upon root over, what will come? This is value is what? T square. So this is t square. So I equals to what will come? This is t square, so 2t dt divided by t into cos of alpha plus beta. So t getting cancelled. 2 by cos alpha plus beta is outside, integration of dt. So this is nothing but t. So 2t divided by cos alpha plus beta plus c. T value if I put here, 2 by cos alpha plus beta into root over sine x plus alpha divided by cos x minus beta plus c. T value is given this one. This value you have to put. So t value is what? Root over sine x plus alpha divided by cos x minus beta. So that value we will put here. So this will be the answer.